So in today's class, we will see transformer, so first of all, what is the transformer? It is a device device which is used to change the voltage of an alternating current without change in frequency and power. Without change in frequency and power. So, which is only changing voltage but not changing frequency and power. That device is called transformer. Okay. Now, how many types we have for this transformer? A number, that is step down transformer. Step down transformer. And second one, that is step up transformer. So these are the two types of this transformer. What are the types? One is step down, another is step up. Now, what is this step down transformer? It changes. Low AC, low alternating current at high voltage into high alternating current at low voltage. Okay. Low alternating current, which is at high voltage, converting into high alternating current at low voltage. Low AC at high voltage, high AC at low voltage. Understand? This is what step down transformer. Now, what about step up transformer? इसका उल्टा है ना? Yes. Yes, it's reverse. So it changes high alternating current at low voltage into low alternating current at high voltage. Understand the basic difference between step up and step down transformer. Is that clear? it changes high alternating current at low voltage into low alternating current at high voltage. Whereas in this case, low alternating current at high voltage into high alternating current at low voltage. Okay, note down this fast. Now let's move ahead. Now, what is the principle of transformer? Principle. It works on the principle of mutual induction. It works on the principle of mutual induction. That is, when current flowing through a coil or magnetic flux linked with the coil changes, and induced EMF produced in the other coil. So I'm writing like this. That is, magnetic flux linked with coil changes and induced EMF is reduced in the other coil. Okay, so it works on the principle of mutual induction. That is, when magnetic flux linked with one coil changes and induced EMF is produced in the other coil. This is what principle of transformer. Now, what it consists? Let's see its construction part. Now, basically, it consists of one primary and secondary coil. This diagram is not necessary in the exam. If you want, you can draw, or else no. You can see here, whatever this is soft iron core. Okay, soft iron core. This coil is called primary coil, and this coil is called secondary coil. Okay, how many coils we have? Two coils. One is primary, another is secondary. Got it? Even you can draw this diagram like this also. You can see here. Now see here how I am drawing this. I'm just drawing step and step down transformer. What is the basic difference? You will understand now. See here. Which one is this ray? This is primary coil, P. This is secondary. Number of turns in primary are less than number of turns in secondary, or you can say number of turns in secondary are more as compared with primary. That's why this is step up transformer. Step up transformer. Now in this diagram, I am drawing more turns in the primary NP and very less turns in the secondary. So which type of transformer is this? Tell me. Step down transformer. Which type of transformer is this? Step down. No, this is primary, this is secondary. Here also NP, here also NS. NP and NS means number of turns in primary, number of turns in secondary. So this is which one? NS is less than NP, and that's why I'm calling it as a step down transformer. Step up and step down transformer definitions already we have seen, but here this primary coil is there in this number of turns are less, in this number of turns are more. If number of turns in secondary are more than the primary, then it is step up transformer. If number of turns in secondary coil are less than the primary, then it is called as step down transformer. Understand? Note down. Yes, finished. So let's move ahead. Now, let phi be the magnetic flux. Let phi be the magnetic flux linked with each turn and NP and NS are the number of turns in primary and secondary coil. Then induced EMF in primary coil is equal to minus NP into d phi by dt. Similarly, ES is equal to minus NS into d phi by dt, and therefore ES by EP is equal to NS by NP. Yes, no? Call this equation number 1. Next, what is the transformer ratio? Okay. Transformer ratio is R, and it is what? It is ratio of number of turns in secondary coil to the number of turns in primary coil. So R is equal to NS by NP, which is equal to ES by EP, which is equal to PS by PP, and also equal to IP by IS, but this we will see later in the last. After this, we can say. So transformer ratio is what? R is equal to NS by NP is equal to ES by EP is equal to PS by PP. For step up transformer, transformer, what is the case? Ns is greater than np and therefore r is greater than 1. For step down transformer क्या होगा बोलो? For step down transformer np or ns is less than np, therefore r is less than 1. Yes, no? Clear? Understand? Note down this fast. So let's move ahead. Now, if we assume there are no power losses in the process of transformation, means from primary to secondary there is no power loss, then instantaneous output power is equal to instantaneous input power. Okay, so I yes PS is equal to IP PP and therefore PS by PP is equal to IP by IS and therefore transformer ratio R is equal to NS by NP is equal to VS by VP is equal to ES by EP is equal to IP by IS. Just current you are getting reverse, है ना? Remaining all are ESS at denominator. In the current case, it is IP by IS. Okay. Next one. Efficiency of transformer. Efficiency of transformer, that is eta, is equal to output power by input power, which is equal to ES IS divided by EP IP, and percentage efficiency is equal to ESIS by EPIP into 100. Understood? Clear? Okay. So for an ideal transformer, efficiency is equal to 100%. Okay. Or eta is equal to 1 also. If you want in percentage, you write 100%, or else eta is equal to 1. Okay, or percentage efficiency is equal to 100%. Understand? Note down this. So let's solve some problems on this. Very simple problem. A transformer has 400 primary turns and 300 secondary turns. If the operating voltage for the load connected to secondary is measured to be 300 volt, what is the voltage supplied to primary? Now see, this question is looking very big, but it is very easy. First you write down given. What is given? Has 400 primary turns, means NP is given. NP is equal to 400. 300 secondary turns, means NS is equal to 300. Operating voltage for the load means is Vs, or you can write it as a ES also. That is how much? 300 volt. And what he is asking, EP is equal to how much? So what we have a formula? NS by NP is equal to ES by EP, and therefore ES into NP divided by NS is equal to EP, and therefore EP is equal to 300 into 400 divided by 300. Yes, no?
400.
This and this will get cancelled. EP is equal to 400 volt. Is it easy? Yes, no?
Yes, sir. Yes,
Sometimes you may get question of 2 marks on this also. So note down this fast. So this is what end of this chapter. Okay. You can try some more problems. We will stop here today. Okay. Bye.
Thank you, sir. Bye.
Thank you.